Hello everyone, welcome back. So now we're going to do a little bit harder problem, or at least it will look harder. It's actually fairly simple, but let's look at it and see how it goes. So this time we have a 20-pound force and it's applied to the end of this hammer. And we're trying to figure out the moment of the force at a right here. Now, this looks harder because like, oh, that's touching just that point, and I've got to maybe figure out an angle. Is it like something like this? You're thinking a whole lot of things here. However, it's actually not that hard. It's just a 2D problem. All you have to do is break up your force into x and y components, and the x and y components of the position vector, which has nothing to do with that point. I'm getting way too much pen there. Has nothing to do with that point. It has everything to do with that point to this point. You just have to know that direction. And you're given that, 18 inches and 5 inches. So everything is here. You just have to break it up into components. So remember that a lot of these problems when it comes to moment look really hard, but they're not actually that difficult. So, like always, pause, try it on your own, and then come back and see how we do it together. Okay, so 3, 2, 1. Okay, you're back, and you've done it, and you did amazingly, or you did terribly. Either way, we're gonna do it together. So, let's watch. First off, you break it into components. This is pretty easy. This is adjacent right here for the fx component, and so it is cosine of 30 degrees, and the fy component would be opposite, so it would be sine of 30 degrees. Be very careful, opposite of our hypotenuse is sine. Adjacent of our hypotenuse is cosine, SOHCAHTOA. Make sure you remember that. It's a very helpful little thing. Okay, and then we just multiply the opposite components. So the y component times the x distance, and the x component times the y distance. Now if you're wondering, well, which one do I do first? Like which one goes in first to make sure I have the right sign? Well, first off, it's r cross f. So since r is in front, you do rx first. If that doesn't really help you, write it out, I, j, since we're only doing two-dimensional, and then write out your rx, ry, fx, fy. Your little magnitude sign here. There is no third component, you don't cover anything, and you just multiply it out. And so you do rx times fy first. You start at the top left and you work your way through. And so that might make it a little bit easier. Just an option. What we get in the end is we have 362 pound-inches, or negative 362 pound-inches. And since this is counterclockwise, it's positive, what we get is that that's 362 pound-inches clockwise. That's the moment. If we want to get rid of that negative sign. So be careful with that. So as you can see, this problem looked hard, but it wasn't actually that difficult. Moving the x and y axis right here is a very good idea. You can do this problem without moving the x and y axis. You can keep it normal like this, make your y axis up, your x axis over. However, that makes it much more difficult, just because you have to figure out a lot more trigonometry. And why do that if you don't need to? So it is okay to rotate your axes if necessary to make the problem easier. So with that, I'll let you go, and we'll do one more example in just a little bit. Have a good day. Bye-bye.